So law of sines, section 8.1. We're talking about today. You guys are going to learn how to find side lengths and angle measures of non-right triangles. Should be a review down memory lane. You guys did do this back in Algebra 2, so I'm just refreshing your memory to connect and finish out our trigonometry units. So this is the formula for your law of sines. It is A divided by sine A equals B divided by sine B equals C divided by sine C. It's the ratio between the opposite sides and their corresponding angles. Okay? The lowercase letters represent your side lengths. The capital letters represent your angles. Okay? Capital letters are angles, lowercase letters are your sides. So when you look at a triangle and it's labeled A, B, C, the side across from angle A is side A, the side across from angle B is side B, and the side across from angle C is side C. Okay? And basically you look at the ratio between each of the side lengths and the sines of their angles, but you only use 2 of the fractions, not all 3. Okay? So it's really going to be based off of what you're given, whether you're going to use A and B, B and C, or A and C. And of course, not every triangle is going to be labeled A, B, and C. It could be D, E, and F, X, Y, and Z. You just base it off of, the corresponding side across from its respective angle. Okay? So, when you use the law of sines, it's not for every situation. You only use it for 3 situations. You use it for a situation when you have angle, angle, side angle, and side, angle. That's when you use the law of sines. Angle, angle, side, or angle, side, angle, that's when you know 2 angles and a side. Okay? That side can either be in between the 2 angles or on the outside, or when you know 2 sides and an angle opposite of one of those sides. Okay? That's when you use law of sines. Okay? Now that the side angle, that does have an ambiguous case. That basically means that not every combination of side lengths and angle measures is going to produce a triangle or produce solely one triangle. And so you have to be careful. We'll talk about the ambiguous case a lot today, just to make sure you guys are able to recognize when you have to check for it. But again, it's only for your side angle situations. Okay? Otherwise, you'll use law of sines normally and find all your side lengths and angle measures. Okay? Oh, have mercy. Okay? Now, like I said, with the side angle situation, there may be 2 triangles. Okay? You may have 1, you may have no triangles, but you could potentially have 2 triangles. Why are there 2? Well, we've been dealing with the unit circle and circles inside of coordinate planes. Remember that in quadrant 2, sine is also positive in quadrant 2, correct? Which means that you can produce a triangle that has an obtuse angle. The only thing is that the calculator, when you type in, when you set up the equation and you try to solve for your angle, the calculator is not going to give you that obtuse angle. And so you have to kind of manipulate the formula for law of sines so then that way you can get your obtuse angle and you can create your 2 triangles. But what you see down there, that picture, is when you'll have 2 triangles, okay? Basically, again, you're given 2 sides, you're given 2 sides and an included and a non-included angle, and basically in one triangle you can have this type of situation, but then there can be another triangle where A is the same length it was in the first triangle, but it's just moved closer. B now goes from an acute angle to an obtuse angle. These 2 pieces stay the same. C, of course, changes, and then side C also changes as well. This is what I was talking about with the ambiguous case. You can potentially have 2 triangles where A is still the same, B is still the same, but C has a different angle measure and side length, and the same thing with B. They'll have a different side length and angle measure. So we're going to look at some situations so that way you can see it and of course to know when to check for it. All right? So let's look at this first situation, this first example. Okay, it's asking me to solve triangle ABC, whose side C is 12, angle C is 55 degrees, and angle A is 45 degrees. Okay, when it says solve the triangle, what does that mean? Find all sides and angles, just like how we did back in, what was that, Unit 5? Been doing triangles since Unit 5. Okay? So, we got to find all the missing sides and angles. We already know 3 out of the 6 pieces. So, let's go ahead and let's create our triangle. Let's label it ABC. It really doesn't matter which way we label it. But angle C is 55 degrees. Angle A is 45 degrees. And side C, which is across from angle C, is 12. Now, how many degrees are in a triangle? 180. So angle B is what? 80. Okay? Because remember, there's 180 degrees in a triangle. So if I subtract the 2 angles I already know, then I can find angle B. And one thing I forgot to ask, and I should have asked it at the very beginning. This situation is an angle side. 2 angles and a side. This is not the ambiguous case. You don't have to worry about 2 triangles, no triangles. It's going to be 1. Okay? So we're going to work it out normally. So right now I got one of my pieces of information. Angle B is 80 degrees. Now I need to find either side A or side B. We got to find both. And so, I mean, at some point I got to do both. Which one you want to find first? Let's do A. So if I'm looking for side A, I use the sine rule, okay? Which says A over the sine of angle A, which is 45 degrees, equals, what part? Am I going to use the B part or the C part? I want to use the C part. Reason why? I know side C and I know angle C. I got to use what I know. I can't have 2 variables. I'm only going to have 1 at a time. So it's going to be C all over the sine of angle C. And then to solve this proportion, I cross multiply. So this is A sine 55 equals 12 sine 45. I cross multiply, then set them equal to each other. Then the last thing I need to do to solve for A, divide by the sine of 55. Because it was A times the sine of 55, so I got to do the opposite. So A, I'm going to type into my calculator 12 sine 45 divided by sine 55. This will be done with your calculator unless one of these angles was on your unit circle. Let's not forget our unit circle, just in case. What mode should I be in? Degrees, and I know this because they gave me my angles in degrees, so I type in 12 sine 45 divided by sine 55. And do we get this? So 3 significant figures would be 10.4. And then, of course, if there were units, we would write what the units were, but we don't have any units right now. Questions? Now I have to find side B. My encouragement to you is continue to use C a part of your solving, okay? Because we were given side C and angle C, so just in case we found side A wrong, we still have a hope of getting side B right, okay? So we're going to set it up. Side B over the sine of angle B, which was 80. And then side C over the sine of angle C. Can you guys go ahead and solve this out for me, please? So I'm going to cross multiply and then divide. And what I type into my calculator is 12 sine 80 over the sine of 55. What'd you guys get B to be?
14 over 4.
Questions on angle side situations? Angle side angle works the same way. Okay, you don't have to worry about any ambiguous case. You are going to have to figure out what the third angle is first and then be able to find your missing sides from there. It is the side angle situations that usually give students a difficulty because they forget about it. Okay? Side angle, that's when you're given two sides and an angle opposite of one of your sides. So let's take a look at this. It says solve triangle ABC. Where side A is 10, angle side B is 14, and angle A is 39 degrees. Now, one giveaway that lets me know that I'm going to have two triangles is that the side opposite of the angle given to me is smaller than the other side. So you see how 10 is smaller than 14? Whenever I see something like that, that lets me know I'm more than likely 99% sure I'm going to have two triangles, which means I have to check for the ambiguous case. So how to do this, okay? For those who might not remember from Algebra 2. You still use law of signs. You still go about it the way you normally would. Based on what I have, what am I going to have to find first?
The third side.
I won't be able to find the third side.
Oh, B.
Angle B. It's always going to be an angle that you find first. Okay? So I'm going to have to find angle B first because based off of what I'm given, that's the only thing I can find. So I need to find angle B. So I set it up. 14 divided by sine of angle B is equal to what? 10 over the sine of 39. Okay? I still solve this how we did before. Cross multiply. How do I solve for B?
You divide by 10.
Got to divide by 10 first.
And then you use like the negative one sign.
And then I have to take the inverse. That's how I get B by itself. So sine inverse, 14 sine 39 divided by 10. That's what I type into my calculator to find angle B. You guys get this? Yes? Okay. So B is 61.8 degrees. Now, this is B in this particular triangle, okay? But you want to make sure you check for your ambiguous case. After you find your first angle, this is when you need to check for your ambiguous case. After you find the first angle, this is when you have to check for the ambiguous case. So what do? You take the angle that you just found and you subtract it from 180. So 180 minus 61 point, that decimal that's still in your calculator. Did everybody get this? Okay. So rounding to three significant figures, that would be about 118. Okay? 118, if this is indeed two triangles, which I know it is because, again, my little trick, side is smaller than the other one. That means that there is a second triangle where angle A is still 39, where side B is still 14, and side A is still 10. But this time, angle B is now 118. Okay? Have I lost anybody up to here?
So you subtract it, but how do you know if that's automatically another angle, like another triangle? Like, let's say you didn't use the trick in the beginning. If it's
well, if I were to place this triangle or this angle inside of inside of a unit circle, this is 61.8 degrees, right? This angle right here is the supplementary angle to it, which is 118.2. Of course, we round 3 significant figures, that's where we got 118. Okay? And so the sine of 61.8 is the same as the sine of 118.2 because first and second quadrants, the sines are the same. So it is always going to be whatever number you get once you subtract it from 180. 180 is the important thing, though.
But how do you know it's automatically another triangle?
Because when I add these two, if it's less than 180, that means I do have a whole nother triangle. So when I add 118 and 39 degrees, 157, there still leaves some amount to reach 180, correct? So then I add those two up and then subtract them from 180 to get my third angle. And if I do get a positive angle, that lets me know I have two triangles. What's that number? 23. Now, it's a 23 solid or 23 point something?
Oh, wait, because, is it, wait, are we subtracting it with the point 2?
Yeah. You want to make sure that you use your non-rounded answer. So actually it's 22.8. So we want to make sure.
So, if we tried, like, on the first example, if we tried to do that,
you wouldn't be able to because you had two angles already. And because you had two angles already, there was only one other number that was going to make it a triangle. It wasn't going to be two potential angles that were going to make two different triangles where those two angles were the same. There's only one number that's going to make it an actual triangle.
So is angle B 118 or 118.2?
3 significant figures is 118.
Okay. But then you don't use that when you're like subtracting it.
Correct. Questions?
So then both of those are the answers?
So you'll have two answers for angle B. You're going to have two answers for angle C and two answers for side C. And all 6 of those are the solving of your triangle. Okay? So you're going to have 2 sets of solutions. One set for the red triangle, one set for the black triangle. And so you'll basically need to find the remaining pieces for both triangles. So right now, in the red triangle, I have angle B. I need to find angle C and side C. In my black triangle, I found angle B already. I just found angle C to confirm that that is indeed going to be a second triangle here. So the last thing I need to find on my black triangle, my second triangle, is side C. Okay, so let's finish up the black triangle. We'll come back to the red triangle. How do I find side C in the black triangle?
By doing the sign.
Mm-hmm. So someone set it up for me.
10 over 30, sine 39, then x over sine of 22.8.
You still got that long decimal in your calculator? Use that long decimal, okay? Because I have to use it for future answer, I want to make sure I'm using the non-rounded answer to do so. So I'm going to cross multiply. And then divide both sides to find side C in my second triangle. So 10 sine of the 22.7 something number divided by the sine of 39 is what? It is 6.15. So then I've completed this second triangle. So then to find C for my first triangle, angle C and side C for my first triangle, there's 180 degrees in this triangle, so I'm going to do 180 minus 39 minus 61.8, that non-rounded answer. I'm going to go back up and retrieve this information in my calculator because I do not want to use any non-rounded answers. So I'm going to go all the way back up to this number right here to find out that angle C in my first triangle was 79.2 degrees. Then I'm going to use the law of sines again to find angle C, side C in this same triangle. So that's going to be C over the sine of 79.2. Of course, I'm not going to use the rounded answer. Then I cross multiply. That's 10 sine 79.2 equals C sine of 39. Then I divide both sides by the sine of 39 to find side C. And that's what I type into my calculator. 10 sine, that answer I just got, divided by the sine of 39 degrees. And side C for my first triangle is 15.6. So I'll have 6 sets of solutions here. I'll have angle B for triangle 1. I'll have angle C for triangle 1 and side C for triangle 1. Then I'll have angle B for triangle 2, angle C for triangle 2, and side C for triangle 2. Let's look at another one using the ambiguous case. Okay? This one you're going to have to actually write down physically into your notebook. We're asked to solve triangle ABC. Angle A is 28 degrees, side B is 6, and side A is 4.8. This is another side-side angle situation. And if you notice, the side across from the angle that you're given is smaller than the other side, which is kind of a key, an indicator that I'm probably going to have 2 triangles here. Okay? So this is going to be triangle 1, and I'm going to have another triangle, which is triangle 2. So what'd you get for B, the first one? 35.9 degrees. After you find your first angle, this is when you check for the ambiguous case. This is when you subtract that angle from 180. So what is what's 180 minus that 35.9 number? 144.1, which will round up to be 144. That could potentially be angle B in a second triangle.
If you add it up plus 28, and you still need 8 to get 180.
So that means I am going to have two triangles. A is still 28. That hasn't changed. A to C is still 6. And B to C is still 4.8. The original three pieces of information do not change. The original three pieces of information do not change. When I add that new angle of 144 and 28 together and subtract it from 180, I do indeed end up getting an angle C, which is 7. Do not use the rounded answer. 7.93. So you round when you are producing the final answer, but if you have to use that answer to get another answer, you use the non-rounded answer. So when you subtract 180 minus 35.9 and whatever the rest of that decimal was, you get 144.0669 and so on and so forth. So you take that non-rounded answer and you subtract it from 180, just like you subtract 28 from 180, to get the last angle of that triangle. And in this case, you are going to have two triangles. You are going to have two triangles, two angle B's, which we both have, two angle C's, we know one of them so far, and two side C's. Find the remaining angle C and the two side C's. So the side for triangle 2 was what? 1.41. Good. Back to this triangle, this first one. If I do 180 minus 28 minus this 35.9 non-rounded number, what was angle C?
116.
Okay, so three significant figures would be 116. So that would be for angle C. Then I would set it up like before to find side C. Remember, anytime we have to use an answer that we found, we use the non-rounded answer. So then that way our numbers can be as exact as possible. So what's side C for the first triangle? 9.18. Again, this only occurs when you are dealing with a side angle situation. The side opposite of the angle given to you is smaller than the second side. And you check for this after you find your first angle. You check for the second triangle. Now, there won't always be two triangles. If you happen to check for the second triangle, you get a number, but when you do 180 minus the sum of those two angles and it ends up giving you a negative number, that means there is no second triangle. And you work it out like normal with the one triangle. Sometimes you'll look for that first angle and you'll end up getting an error message. Like it'll say domain, invalid domain or something like that. I think that's the message it says on your calculator. But you go back, double check your work, make sure you didn't do anything wrong, and you get it again. That means there's no triangle. Okay? So no triangle, you'll know from the very beginning. So from the blue, you won't even be able to get that first angle. That means there's no triangles that will fit whatever the requirements are. Okay? And that is how you use the law of signs to find missing side lengths and angle measures of non-right triangles. Non-right triangles. Not right. Non-right triangles.